here, and we discussed about the in the last class we discussed about this chemical. Uh, First, we discuss the physical techniques, and thereafter we discuss about the brief about chemical techniques. So, chemical techniques, how it is going to be worked. In the last class, we have discussed, and in briefly we discussed in the chemical technique that there are three types of workout is there. One is said to be the, if you remember correctly, what we discussed last time. This. So we discussed here that one is about the precursors, what precursors we are actually going to take, and that precursors need to be reduced. So in order to reducing this precursors in terms of the salt, in terms of the salt and their ions, and next is about the when it is to be just dissociated, then we require the capping agent, then we require the capping agent, and which is going to make the encapsulation of those nanoparticles what has been prepared here. In the that line, the third is biological synthesis of nanoparticles. Actually, biological synthesis is why actually biological synthesis, since ultimately in the and chemical, physical and chemical, rather in a chemical, it is more actually you can say toxic, toxic in terms of the toxic in terms of the environment, as well as in the soil, since ultimately whatever the product you are going to prepare, ultimately they are going to disposed of in the soil. So for that reason also they are not that much actually, since they are not going to be they are not going to mix up with the soils, or you can say they are not degradable easy, they are not easily degradable. So in order to, since they are not easily degradable, for that reasons actually these chemical methods or the physical methods are not generally preferred. Rather, since chemicals are the same, so for that purpose, if we do have the chemicals, then in order to reducing it, at least either we go for the extractions of those metals from the plants, or somewhere else what is to be you can say environmentally available, or you go through the different types of their reductions. If you do have a precursors, those precursors are going to be reduced in the chemical process. You are using the chemical here, but in the biological methods actually the via reduction process is going to be done via either the virus, yeah, or you can say bacteria, or you can say fungus, or fungal or fungi, whatever you say, or you can say extraction plant extraction. So whatever method you are opting, any of the method you can use in order to reduce your chemicals, and for that reasons they are more environmental benign. So these materials, whatever nanomaterials are going to prepared using the biological method, they are more environmental benign, so they are more useful to the environment, and they are very much you can say people are preferring such types of materials, and especially in the medicine, or the nanoparticles where directly they are in the interaction with the living organism, they mostly prefer the reductions of the those salts are going to be take place using the biological methods. So you can see here, like food wastes are there, and they prepared their extracts, means they are going to dissolve it anyway, and their aqueous solution is going to be formed. And once aqueous solution is going to be formed, you just make your precursors ready in the either in the distilled water or the appropriate solvent. You mix them together, and once you are going to make them together, then whatever reactions takes place here, they are going to say the biosynthesis of nanoparticles. So whatever materials are going to prepare here, ultimately if you have to see that capping agent requires or not. If capping agent required, then you have to go for capping agents, you have to add the capping agent, but it is going to work out using the biological methods. So this is the way out, that metal salts are there, food waste extract solution are there, they are going to form the metallic products, and some byproducts are there, they are going to be filtered out, or they are going to the actual nanoparticles are going to settle down at the bottom, and the rest of the things are going to be just floating over this material, so they are going to be extracted it out, or you can separate it out by any means. But capping agents requires here also, since you see here the capping agents are going to be used in order to make the stable nanoparticles. The stable nanoparticles means what your nanoparticles have been prepared, they are not going to degrade. In the other way, that microorganism or plant extracts. So here what people are doing the same way, the metal salts are there, so production of heterogeneous nanoparticles with low yield, although yield is not that much, but it is going to be done. Incubation period, mixing ratio, temperature, pH, and aeration. So all these parameters, what you need, they are the processing parameter. But ultimately, what you have to do, what your plants are there, those plants actually, suppose if they have their cavity, or you can say you are taking a plants directly, their stems you are taking it out, or you are taking their leaf, or you are taking their, you can say what you are going to say, that sealed the upper side of those plants, if you are going to take it out and you are going to dissolve it somewhere, from there you are going to extract the metals, so that is also different. Actually, they are also comes into the category of biosynthesis of nanoparticles. So ultimately here, on the basis of this pH, temperature, and in the basis of timing, how much time you are going to put it for this extractions of metals, they are going to decide that which types of nanoparticles are going to be formed. So nanoparticles can be, their shape can be controlled based on these parameters, what has to be given here, 5 parameters. Apart from it, if you see, there are 2 types of nanomaterials are going to form. So if we are talking the nanomaterials, in nanomaterials, both the category, either it is going to form the nanoparticle, or it is to be formed the thin films. In both the cases, you are saying these are the nanomaterials. So thin films are going to be prepared by the different techniques, and nanoparticles are going to be prepared by the different techniques. So I'll mention that which are going to prepare the thin films and which are going to prepare the nanoparticles. So if you look the sol gel process normally used in order to prepare the nanoparticles. It is normally used to prepare the nanoparticles. It's a very robust technique. Actually, if you don't have anything in your laboratory, then most of the time people pass through the sol gel synthesis, since it requires normally a beaker, it requires a magnetic exterior, and an oven requires. That is sufficient in order to go through the sol gel process, and precursors obviously you requires. So one precursors are there, and those precursors are, if it is the sol gel process, then one precursors are there. Mostly solvents are distilled water people are using. So if distilled water, they are going to dissolve in the distilled water, then hydrolysis is going to occur. So hydrolysis, what they are going to do, whatever ROH they are going to form, and MOH is going to form. So ultimately, whatever MOH is there, they are going to form the ultimate your metallic compounds, and H2O is going to evaporate. And thereafter, if you look the series, then ultimately it is your complete reactions. So you can put here on the basis of metals, you may put silicon, germanium, titanium, cobalt, anything you want, you put here, and your materials are going to be prepared. So ultimately, what is there are the sol is going to be formed once your precursors are going to dissolve in the distilled water, then whatever the solution is going to prepare, that is said to be the sol. And thereafter, in the sol, solid particles of a diameter of few hundred nanometers are found in the liquid phase. Then the particles condense in a new phase. So once you are going to keep on stirring and giving the little bit temperature here, then what is going to happen? It is going to transform from the sol to gel form. They are going to form in the little bit their viscosity is going to be increased here. So they are going to set to be the gel which solid macromolecules immerse in a liquid phase. Instead of this small solid particles, it is going to convert into the macromolecules here once it is into the gel format. Thereafter, drying the gel by means low temperature treatment, means around 60 to 80 degrees centigrade, it is possible to obtain porous solid matrix. So that is said to be the porous solid matrix, is said to be the zero gel. So remember this terminology. Although it is said to be the zero gel, but once solid gel process you are using for your materials, nanoparticles, then you are going to get it out that is nothing is the solid matrix, what you are getting the ultimately powders after drying it once gel is going to be formed. The fundamental property of salt gel process is that it is possible to generate ceramic material at temperature close to room temperature. So ceramic materials are mostly preferred to go through the salt gel process. Therefore, such a procedure offered the possibility of incorporating these glasses soft dopants such as the fluorescent dye, means these are the some materials, organic chromophores, those are the materials which are mostly preferred to go through this salt gel process. So same thing is actually written here. It is the same traditional terminology. Here you can see that whatever the solutions are there in distilled water, it is here, but depends on that how you are passing it. Then hydrolysis, polymerization, then salt is going to prepare. Then after once salt is going to prepare, you can go through the spinning, you can go through the precipitations, you can go through the this extrapolation, means something different way zero gels you required you can go through, or extraction of solvents, means you are going to remove the solvent, whatever is going to be left with, that is said to be the aerosol, or directly you are going to from here directly you are just drying it and you are going to deposit it somewhere at some substrate. If substrate you are going to prepare, then it is said to be they come into the category of thin films. They are in the category of thin film. So this is the way out how salt gel technique is going to be used, and based on the conversion of salt to gel, it is said to be the salt gel process. So if anyone have any query related to salt gel process, you may ask the students. Students, are you there?
Yes.
It's okay, or I have to move ahead? Or anyone have any query? No. Okay, so ISPE pyrolysis, actually ISPE pyrolysis, just I want to show you the this equipment. You can see this equipment in the Dr. KY lab. So this is already available with us. I don't know how many of you are working over here, but it's in our department. So in the ISPE pyrolysis, actually, as name suggests, if you see the terminology, then spray actually something is which is to be spraying the materials over any substrate, and pyrolysis is simultaneously it is going to be heated up. So if you are going to prepare such a film that you are spraying something, if using the nozzle, you are spraying off any substrate, and at the simultaneously this substrate is heating by the same time it is to be heating. So whatever the wipers, whatever the you are spraying over here, they are going to be dry soon. So a film is going to prepare over the substrate. So this is said to be the ISPE pyrolysis technique. So let us go through the line by line. The chemical ISPE pyrolysis techniques has been used during last 3 decades. It is one of the major techniques to deposit a wide variety of materials in thin film forms. The pristine requisite for obtaining good quality thin films is the optimizations of preparative conditions, which substrate temperature, spray rate, concentration of solution. So you can see here what types of substrate you are using over which your thin films are going to prepare, how you are spraying, how you are going to done, how is their pores from where spraying is to be done, how is nozzle, how far it is, how close with the substrate. So those things will matter. And obviously what solution you have put there, is it's not that much jelly. If they are so much jelly, then spraying may not be done in that way. So these are the important points where actually ISPE pyrolysis has to look so far. However, in the last few years, an emphasis has been given to a variety of atomization techniques such as ultrasonic nebulizations, improved spray pyrolysis, hydrolysis, corona spray pyrolysis, electrostatic spray pyrolysis, and microprocessor-based spray pyrolysis. So these are spray pyrolysis different variety, how they are going to work and where they have to improve things. Ultimately, where you have the nodules, how you can improve that parts, where how drying is going to take place, how this electrostatic spray pyrolysis means if you have the ionic type materials, then how it is going to work. So all these things are self-controlled. Once you are going to fix the time, automatically it is going to work. So those things are available in the upgraded version of spray pyrolysis. The most critical parameter as it enables controls over the size of the droplets and their distribution over the preheated substrate. The enhancement in the deposition efficiency and improved in quality of thin films can be achieved with these atomization techniques. So here the droplet size dispersion, atomization rate, droplet velocity. So these are this droplet size is to be related to the size of end particles. Size dispersion determines the homogeneity of end product, and atomization means scalability of process is affected. Means if you are looking for industrial scale, then certainly you have to do the atomization. Droplet velocity affects residence time within the furnaces. So this already I have shown you. This is the figure what we are having actually here. So these are the spray gun. These are the precursor solution reservoir where it has been to be put. This is said to be the nozzle where spraying is going to be done. This is to be the substrate. And if you see the bottom is spilled plate and thereafter heater is here. So power supply is going to be done here. It is going to heat it up, the steel plate. And steel plate is substrate is covered this steel plate. So it is going to heat it up. Whatever the solution are coming over here, they are going to dry soon. These are the pressure regulators, compressed carrier gas. So it can be done in the controlled atmosphere also. So here in this region, you may control you can put the control of any of the gas. So if you want to do your measurement in the presence of any gas, then you can do this. You can control here pressure also. You can control here the environment, complete environment. You can control here in the advanced spray pyrolysis techniques. So these are the actually features how they are going to actually this sintering, decomposition, dyeing, precipitations, evaporations, how these things are going to occur. This is the way out actually. If your materials are there, then once your materials are going to spray over the substrate, then certainly vaporization is going to be take place. Thereafter, it is going to form into the solid form once it is to be completely dried. So these are the benefits. Actually, benefits if you see does not require high quality target or substrate. Means it is very easy to handle. So this is the benefits and limitations. If you say, then it's you have to look these you can say the points where you have to take care. That's solute concentrations. You have to take care of this atomization techniques. You have to take care of temperatures. You have to take care of residence times. You have to take care of what gases actually you are looking so far in the this spray pyrolysis techniques. So these are the 2-3 things what actually I discussed today. If anyone have query, you please ask. Otherwise, I am going to leave you here, student. Students.
Yes, sir.
किसी को कुछ पूछना है इसमें? हमने थोड़ा फास्ट में चला हूँ. अगर किसी कुछ पूछना है तो आप पूछ सकते हो. विदाउट एनी हेजिटेशन, अगर किसी कुछ पूछना बिना हेजिटेशन के पूछ सकते हो अपने तरीके से. कुछ ऐसा नहीं है कि हम क्या बोलेंगे या ऐसा आप नहीं जानते हो पहले से, ऐसा कुछ मैं नहीं कुछ कहने वाला हूँ. अगर आपको कुछ भी पूछना है इन 3 चीज के, जो 3 चीज हमने बायोसिंथेसिस, कैसे बायोलॉजिकली हाउ वी आर प्रिपेयरिंग द नैनो पार्टिकल्स, हाउ वी आर डूइंग दिस स्प्रे पायरोलिसिस, हाउ वी आर डूइंग द सॉल्ट जेल. So I think most of you have gone through the salt gel techniques, and I'm not sure, but I can say that no one is using right now spray pyrolysis. Am I right? कोई है जो इस पे फाइलोसिस यूज कर रहा है? स्टूडेंट्स, है कोई?
No, sir, I don't think so.
So this
Sir,
is the
can you send this PDF, sir? All PDFs.
once this unit is going to over, thereafter I will share with you. Till date, you just be ready, since the type test I am going to ask before sharing this PPT. So just you be ready. Okay? And once one unit is going to over, I am going to share that unit's PPT with you. Is it okay to you all?
Sir, before sharing PPT, can you will take ST, sir?
Surprise test.
Sir.
Abdul, Diya,
sir.
Diya,
सर अभी तो कुछ नहीं
Ikshita,
सर.
Ikshita,
Present, sir.
Kalpana,
Present, sir.
Kiran,
Present, sir.
Sudeep,
Present, sir.
Magan,